Okay, here's an intro video to Experiment 2. Experiment 2 is about how to determine mass and volume using different pieces of equipment in the lab, and then using those values to calculate density of different types of substances. So here you'll see this table. There's 4 different metals here. You'll need this for part C1. So when you go to find the density of your unknown metal cylinder, you will need to come here to see who your metal actually is when it asks you for your identity. And you'll just compare and see whose density is the closest to your measurement. Here's the procedure. I'm going to talk through that once I get to the data sheet. If you're using glassware and you're measuring the volume of a liquid, the liquid's always going to create this curve, and we call that the meniscus. You're going to always want to record the volume at the bottom of the meniscus. So that's number 1. You want to pay attention to that. Secondly, you want to think about significant figures. So different pieces of equipment will have different increments on it. Here we've got 6.1, 6.2, 6.3, so every increment is a tenth of a milliliter. Well, we always want to estimate 1 digit. So what you want to do is go 1 digit beyond the smallest increment. So here we know this is 6.6, and then we estimate 1 further digit. So this person recorded this as 6.60, which is really important because it makes it 3 sig figs, and it indicates to the reader that only that 0 is estimated, that the other 2 values are actually on the piece of equipment. So keep that in mind as you have to measure different liquids. That will also go for thermometers in future labs. So here, if I run through the lab report sheets that you'll be completing, you'll complete pre-lab, and then on the lab data sheet, you'll watch the video here and record and draw the flame that we talk about in the video. Part B, I'll be massing different objects using the scale, so you'll get these values also from the video. And then for the mass of 7 mLs of water, you'll get the mass of an empty cylinder, which we'll do on the video. We'll add 7 milliliters of water, and then you'll get a measurement here. And what you'll need to do is subtract, because this is the mass of the cylinder and water. So what you need to do is subtract out the cylinder so that you're left with just the mass of the water here. And when you do this, be careful to subtract using significant figure rules, looking at number of decimal places. These values are actually given on the data sheet. And then you can calculate all of the masses of water there. When averaging, you can use the same number of significant figures that you have in your water measure. Here you will find all of the data for part C, either in the videos and or on the data sheet. But what I want to do is run through one sample calculation here, mostly just to remind you of the significant figure rules. So if you took your metal cylinder, because that's what we're working with here, is a piece of metal, and you massed it, and let's say its mass was 39.293 grams. And then you took a graduated cylinder and you filled it halfway with water, and the water alone had a volume of 20.51 centimeters cubed, or the same thing as milliliters. Then you drop the solid into the water. That causes the water level to rise. So if the water level rose to 26.61, what we can then do is subtract here If we have the water and solid, we'll subtract out the water so that we get the volume of just the solid. So when I take 26.61 and subtract 20.51, I also have to think about significant figures. Since this is subtraction, I'm going to look at decimal places. This has 2 decimal places. This has 2 decimal places, which means this calculation needs to have 2 decimal places. So this would be 6.10. And it's really important that we keep that 0 because that gives this value 3 significant figures rather than 2 if I had left it off. And then density, lastly, is mass divided by volume. So we'd take our mass up here, the 39 grams, and divide by the volume of 6. Now that we're dividing, we've got to look at sig figs. So over here I would say, well, the mass up here has 5 sig figs, and the volume has 3 sig figs. So therefore my density will be limited to 3 sig figs. So when I divide the 39 divided by the 6, that will round to 6.44 grams per centimeters cubed. And then you'll go look at the table and see who has that density, which metal matches closest to that density to get your identity. So make sure you use the sig fig rules really carefully along the way, all the way through these density measurements. And then you'll complete the post-lab questions.